a region R is bounded by the curves, right? And there's nothing else, no other information that you need. There is the only region that is bounded sufficiently by the curves. Okay, a couple of you tried to go with a coordinate axis and inevitably got confused because you'd get an infinite area and so an infinite volume. So you have to find the coordinates. That wasn't too hard. When you solve, you've got 1, 2, 3 points, and the coordinates are minus 220, 0, 12, 2, 4. Okay, so where were the marks? 1 marked for solving these simultaneously, which gave you your x values. The second mark was for then putting it back into either of the equations, you know, if you were smart, that one, to get your y values. 1 mark for actually getting these graphs decent looking, okay? So you had to have curvature and all that kind of thing in a reasonable sense. And then the last mark was for getting that region right. X, Y, graphs, regions, 4 marks, right? An easy 4 to start you off. Now, part 2. You then had to find the volume, and it was prescribed for you which method you had to use. By taking cylindrical shells, show that the volume generated by going around the y-axis is, and then there's the number, okay? Now, this part wasn't necessary, but like I said, when you didn't do it, or you did it badly, you sort of really hurt yourself. The volume I'm going to get is going around here, okay? So firstly, I mean, I could draw the entire volume, but it's just going to get confusing, okay? So instead, what I'm going to do is I'm just going to take 1 cylindrical shell, right? Now, when you've got shells, are the areas parallel to the axis of rotation or perpendicular? Which way? They're parallel, right? So I'm going to get an up-down kind of area that's going to become the shell, right? So when I rotate this around like so, here's what I get. Okay, there you go, and you can see it on the photocopy, right? Now, what proceeds from there is I was looking for, number 1, first mark, the actual volume expression, okay? Now, can you see, by the way, see how on my diagram, I can see what the height is supposed to be. It's quite obviously that's the height, okay? Some of you went straight to saying, look, I can consider this as an unfolded, you know, cut up cylindrical shell, which goes to this, right? But then you might have gotten some of your dimensions confused, which would have confused your integral, okay? So when I see it here, I have a look and I think, well, clearly it's going to be one graph minus the other, right? At least for this one that I've taken, and I'm going to consider just one half of it because there's symmetry here. The cubic graph is on top of the linear graph, right? So I'm going to subtract this from this. This from this. So that's how I get 4x minus x cubed. Okay? Can you see that the 12s cancel? There's going to be a double negative on that -4, so that's why it becomes 4x minus x cubed. Right? So therefore I can say, I can put in my summation statement. Okay? The volume is equal to the limit. Okay, which way are my slices? Again, sorry, my areas. A good diagram helps you out, because look, I can see that's the width I'm interested in, right? And look, I drew it in horizontally, so clearly it's delta x. Okay, so I'm going to take the limit as delta x approaches 0 of... Okay, now, where shall I add up? What are my boundaries going to be? Okay. And you had a couple of choices here. The way I went about it was I said, I'm going to consider it from 0 to 2. From 0 to 2. Okay, I could go from -2 to 2, but I'm going to take advantage of the symmetry of this to halve the value that I've got, that I'm going to integrate, and it gives me a nice easy thing to punch into my integral. Okay, you do need to justify that. So when I finish this line, here's my 2 pi, there's my radius, right? And then here's my height function. Okay, the reason I can justify this is by saying I would make a statement about, due to the symmetry of R, I can take this volume and double it rather than considering the whole thing. Okay. There's a bit of a longer way to say it, and you can have a look at my full writing if you're not sure about the wording. Okay, but I didn't actually put marks on there because I would have put like half-half, but I don't do halves. Okay. Right, so from there, I can take out my 2 pi, I can tidy this up a little bit, it gives me the integral, right, like so. 2 pi, 0 to 2, 4x squared minus x to the 4. dx. And now I'm integrating. Okay? So there was nothing from here to here. There's not much consequentially. But when you actually do integrate, there was the second mark there. Okay? So, oops, sorry, I missed something. Like I said, because of the symmetry of R, you've got to double this volume, right? That'll give you the whole thing. This is just 0 to 2, 1/2. So if I slap a 2 out the front, that'll give me the whole volume. So this actually should be a 4. Okay? So I get 4 pi, I'm going integral, let's see, 4x cubed on 3, x to the 5 on 5. There was your second mark on actually integrating. Your third mark was in here on the actual evaluation. Okay? Now because you were given the result, and this happened again and again, your actual result's down here, right? Okay. Because you were given this result, if one mark is here and a second mark is here, you cannot expect a third mark for free for writing down what you already know. Okay? So therefore, this line in here where you actually evaluate the upper and lower bounds is important, vitally important, right? And so what do you got in there? You got 4 pi outside of, you should get 4/3 minus 1/5. Sorry, what am I talking about? 4 times 8, 32 on 5 minus 0. Okay, I wasn't too fussed if you didn't say 0 minus 0. I think that's okay. It's clear that it's 0, but at least you evaluated it. And then out comes your number. Okay, 3 marks. 1, 2, 3 on the actual evaluation.